Hello, in this video we're going to work through this problem here. So, the flight path of a firework is modeled by the relation h equals -5 t minus 5 squared plus 127, where h is the height in meters of the firework above the ground and t is the time in seconds since the firework was fired. A. What is the maximum height reached by the firework? How many seconds after it was fired does the firework reach this height? And B. How high was the firework above the ground when it was fired? So, the clue as to how to do this problem is actually right here. What I notice right away is the height of this firework is modeled using a quadratic. Specifically, it's modeled using a quadratic that's given to us in what's called vertex form. So over here, I have a little bit of theory I'm going to write down about vertex form. So, just like when you're working with linear relationships, if you have the form y equals mx plus b, you know the slope and the y-intercept. If you have a quadratic in vertex form, you know some information about that quadratic. You know A. A is what's called the vertical stretch factor. So, what we, a little bit of exploration here is that if A is greater than 0, it opens up. And if A is less than 0, it opens down. H is what's called the horizontal shift. So, if H, we have a situation where we have x minus h, we shift h units right, and if we have x plus h, we shift h units left. Now it seems like that's wrong because on the coordinate axis, right is positive and left is negative, but in fact there's some reasoning for this, and I do encourage you to do a little exploration and understand why it's the reverse of what you might think intuitively. K is what's called the vertical shift. So if K is greater than 0, we shift up. If K is less than 0, we shift down. So, when we learned about quadratics in vertex form, we said regardless of the question, we always want to be able to do a quick sketch to help us understand and kind of get a picture of what this looks like. And again, in vertex form, we can make that sketch as long as we identify some key attributes of a quadratics from it. Our key attributes that we want to make sure whenever we look at a quadratic that we identify are, let's change the color here. The key attributes we want to identify are the direction of opening, and if it has a max or a min, and if so, what is that point? Now we're going to pull these off pretty quickly, but again, it's good to go back and understand why we can read this information from a quadratic in vertex form. So the vertex is always in the position HK. The direction in opening, like we say, if A is greater than 0, it's up. And if A is less than 0, it's down. the axis of symmetry is always an equation of a line, and it always passes through the vertex. So it's going to be x equals k, sorry, not k, pardon me, x equals h, and max min can be told by our direction of opening. So if a is greater than 0 and it opens up, that means it has a minimum, and if a is less than 0 and it opens down, that means we have a maximum. Now, of course, as we discussed in class, this is assuming that the parabola is defined for all x values. There's, of course, some kind of neat little things you can do to change that. So the first thing I'm going to do is, when I get this question, before I try and answer the questions, I'm going to draw a quick sketch. It's really important that we get in the habit of always kind of drawing a sketch to see if we can get an idea of what this looks like. So again, a quick sketch requires no scale, just is going to give us a feel of what this looks like. So I see right away that a is negative, so it opens down. I see that the vertex is going to be at 5, 127, so I'm going to come over 5, and I'm going to say this is 5, 127, and it opens down. Now, I know a branch is going to do this, but the question is, now this branch, how is this going to kind of come down? It's going to come down and kind of cross there. Is it going to come down, cross down there? I'm not exactly sure. So what I can do when I have a sketch like this is I can actually just calculate a point quickly. So let's take h when t is equal to 0. So h is equal to negative 5, 0 minus 5 squared plus 127. And now what I'm going to do is I'm going to get my calculator out. I'm going to put this in my calculator in one step. It's really important we become confident using our calculator so we can do these kind of quick calculations. So let me just clear my calculator. So when I type this in my calculator, I get a value of h equals 2, which actually makes me feel pretty good because of the fact that if I'm firing this firework, I'm probably firing it from a handheld position above the ground. Dot, 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 dot. It's really important when you put a point on a sketch that you actually label it. This is obviously not to scale, so it's really just to give us a feel of what this looks like. So now, with this quick sketch that I've done, I can actually answer part A and part B without any real additional work. So it says, what is the maximum height reached by the firework? Well, the max height, the max height reached is 127 meters at 5 seconds. The second part says how high was the firework above the ground when it was fired, and so part B, it was fired at t equals 0. So that's the main idea here. So therefore, if it was fired at t equals 0, we just substitute 0 like we did down here, and we get it was fired at a height of 2 meters. So I hope that helped. Before I close off here, I'm just going to come back over to this section here and talk a bit more about the theory. So think back, always connect this to linear relationships. You're really doing the same thing when you're trying to sketch these. You're taking some relationship that you know the general shape of, and then you're identifying key features. With the quadratic, those key features are the vertex, the direction of opening, the axis of symmetry, and if it has a max or a min. These are features unique to a quadratic. It's always good, if we can, to find the x-intercepts, and we find those by setting y equal to 0 and to find the y-intercepts. And we find those by setting x equals to 0. And in our sketch, we might want a couple other points to help us out. So a really critical point of a quadratic is the vertex. So if you want to add a couple points, we can do that by selecting x values close to the vertex. And calculating y. Now again, this is not a hard and fast rule you always do, but it's something that it makes sense because the vertex is often a critical point in a quadratic that tells us an important piece of information. So I hope this video helped, and as always, if you have any questions, please ask.